Electricity is a fundamental part of everyone's life now and age. Through much work and study from past scientists and physicists, we have been able to understand a bit more of how it works and how it interacts with objects all around us. Most objects can be placed into two different categories, conductors and insulators. Although there are several other categories, such as semiconductors and superconductors, today we will assume that everything fits in these two categories to make it a little easier to understand. As you see here on the right, we have a glass rod, and on the left, we have an iron rod. The glass rod is an insulator, while the iron rod is a conductor. But what makes them fit into these categories? To better understand this, we must go to the atomic level of things to show how this works. First, let's start with the conductor, or the iron rod. When we look at the makeup, we see several atoms in the rod that are unable to move freely. The atoms are made up of a nucleus containing protons and neutrons, making the nucleus positive, and just outside of the nucleus, we have electrons, which are negatively charged flowing around it. Since we know that the atoms aren't moving, what makes the iron rod a conductor is when there is an electrical current hitting a rod, the electrons have the ability to jump from one atom to the other in this manner. When we look at the atoms of the insulator, or the glass rod, the atomic makeup is similar. A nucleus with protons and neutrons, and electrons flowing around it. But the key difference is that insulators don't have the ability to transfer their electrons from one atom to another. That means if an electrical current hits the glass rod, the current will stop there because it won't be able to transfer the energy from one end to the other. Now I am going to explain a little bit about how conductors and insulators can interact with each other to transfer charges. First I'll talk about charging by contact, and a little later I will talk about induction. So as you can see in the image, we have an insulator. The glass rod, that was rubbed beforehand to get positive charges on the surface. We also have a conductor, which is the electroscope, that has a net charge of 0 at the moment. Once we touch the glass rod to the electroscope, the negative charges of the electroscope will transfer to the glass rod since there are so many positive charges on the glass rod. We then remove the glass rod, and what's left on the electroscope is a net positive charge due to the fact that some of the negative charges transfer to the glass rod, making the electroscope or the conductor charged. This is the principle behind charging by contact. Next, we will talk about charging via induction. As you can see, there are two metal spheres in contact with each other, with an evenly distributed amount of negative and positive charges. There is also a glass rod in the corner that is charged with positive charges, because it has been rubbed before. When you bring the glass rod close to the metal spheres, without allowing them to touch, we see an effect in the metal spheres where the negative charges will group up on the sphere closest to the glass rod, and the positive charges will go to the metal sphere that is farthest away. This is because opposite charges attract, and like charges repel. While keeping the glass rod close, you can separate the metal spheres, which will cause the negative charges to stay mostly on one metal sphere and the positive charges to stay mostly on the other. We can then remove the glass rod, and once we do that, the negative charges of one sphere will group up towards the edge of where the other metal sphere is, and the positive charges of the other metal sphere will do the same towards the other sphere. This is the principle behind induction, using a conductor and an insulator. Okay, so here I'm going to show what materials are conductive and what materials are insulative using a circuit system. Here we have the power supply, we have the switch, we have the ground just in case for safety, and then also the neutral. And then right here is where the conductor or the insulator will go, and we'll show that that this device lights on if it's a conductor and it won't when it's an insulator. And the conductors I'm going to be using today is aluminum, copper wire, and iron. And then the insulators is plastic, and then the insulator that goes around a copper wire, and then a piece of wood. So the first conductor we're going to show that it is a conductor is aluminum. And as you see here, we got to connect it to the system. So I'll go ahead and turn on the light and you'll see that the light bulb turns on. Okay, next I will show that copper wire is also a conductor. So we have it connected to the system. Let's go ahead and turn on the light. The last conductor I wanted to show was iron. So here we have the iron connected to the circuit, and we'll go ahead and turn on the light. Okay, so as you can see, I've completed the circuit with an insulator, which is plastic. And I'm going to show you now that electricity doesn't flow to the light bulb by turning on the switch. So as you can see, the light did not turn on, but just to make sure and show you that there still is voltage, I'm going to put my multimeter to these terminals and we'll see that there is 120 volts, but that voltage doesn't reach the actual light bulb. Okay, so same as last time, I'm going to show you another insulator, which is the insulation that goes around the copper wires. And I'm going to show you this by turning on the light bulb, and you'll see that the light bulb actually does not turn on, but there still is voltage going through these two terminals of 120 volts. So the last insulator I would like to show you is putting a piece of wood in the circuit. So as you'll see, it's we turn on the power and there's no light. So the wood is an insulator. And just as before, we're going to show you that there still is voltage in the terminals.